Do you all have your scoring sheets out? Mm-hmm. Before I start on this, I thought I'd just, this is about tips and tricks, right? So a few tips and tricks. One of the things that people really struggle with is when they get up and they're going to open their presentation and they're nervous, so their hand is shaking, and you're trying to move the pointer down into the right-hand corner and find this darn place here where you start your presentation, right? Anyone had that feeling at any time? So here's the trick. F5. F5. Just push F5. That'll never happen to you again then, okay? And here's the other trick. Sometimes you want to draw the attention away from the screen and to yourself. Because now I'm not giving my presentation, I'm talking about something entirely different. So what did I do? How did that happen? I pushed the period key. So if you push the period key, what the computer does then is send a black screen signal. It doesn't interrupt the presentation. The presentation is still there. If I push the period key again, the presentation will come back, all right? So these are two tricks. And then we had there's a third point before I start this presentation. And we had a little bit of a discussion over the tea break here, and that was about movement. And you have now, since I started talking about movement, probably been looking at Eric, what his style is, and you've been looking at Ivan and his style behind the podium, and what happened now? I got your attention, didn't I? Whereas if I'm standing here talking to you like this, where is your attention? It's not about what I'm saying. You're annoyed, irritated, because I can't stand still. So movement on stage is definitely okay. Definitely okay, because that's an attention grabber. I'm now getting your attention. Am I not? Whereas when I'm standing still behind here, I'm hoping that I have your attention. And when I say hoping, I mean, if I'm looking at the screen or looking at my computer, I have no idea if I have your attention, do I? So the other reason why I want you to be looking at the audience as you speak. So remember, once at every person in the room, every 60th second. Someone said 45 seconds between each time you look at someone. Because that is especially Rod, probably you're more at 30 seconds of attention span. Yeah? So your attention span is about 30 seconds. That means I have to look at Rod every 30 seconds to get his attention back to me. If I look down at the screen here as I'm talking, I'm going to lose you. You're going to start thinking about dinner or what you're doing tonight or whatever else there is. The other advantage of looking at each and every one of you as I speak is that when I sense that I'm losing your attention, now I've lost them. I know I've lost you. What do I do? Now I have your attention. Very simple trick, but very important if you want to keep the attention of the audience for a 15-minute talk, let's say a 45-minute talk. It's impossible to be focused as a speaker for 45 minutes straight. I have to use all the tricks in the book if I'm going to grab your attention and keep it for that long. All right? Now here's the final trick before I start talking about what I'm meant to be talking about. And that is, if you use it with a new PowerPoint version, if you use the, if you start the presentation the way I do, my screen looks like this. This is why I'm using my computer and not the computer here. Can you see what I can see here? I have the current slide and the next slide. Of course, when you've rehearsed your presentation, you know what the next slide is, and then it's much easier to move to the next slide. But this is my trick. Now I know what the next slide is. So that will mean that my moving from one slide to the next, I anticipate the next slide. So the transition from one to the next is much easier. So that was the final trick. Then I'll start talking about what I was meant to talk about, right? No, there's one more. There's a fourth. Have a pointer in your hand and know your pointer. So if you're giving a presentation where somebody else is giving, providing the equipment, show up early, get up on the podium, so you know that when you get up on this podium, how many of you were surprised when you were looking out this morning and you couldn't see the audience? Why couldn't you see the audience? Because there's a strong light in your face. So if you don't know that, then you're going to be a bit nervous, or, you know, how many of you had that feeling? Yeah, got up here and it's, oh, wow. So get up here, familiarize yourself with the podium, with the computer you're using, make sure you have a pointer, because you don't want to be looking down to find the next button. You want to have that in your hand, right? That was it. That was 4 tips and tricks starting out. So, there's one thing that you should remember from my presentation this morning. And that one thing is, you are a storyteller. You're telling a story. Your presentation should be a story. And the other thing you should remember from this morning is that you are telling a story. Your visuals, they are there to help you. And now this visual is helping me, isn't it? It's not competing with me, it's helping me. But it's you who are telling the story. If I stand like this, look down at my computer, I can say the same words, and I can show my slides, but that's not going to be the same thing as seeing me telling the story. Helped by my visuals, but not competing with my own visuals. That is never a good combination. What this presentation was about, I think, Richard, was how to present your data. So how do you present scientific data? And I'm happy to see that what you did, Eric, and what you did, Ivan, is quite complementary. Mm-hmm. Because it's going to be about, so this is the situation where you have some data, whether it's your data or somebody else's data, that you want to present to an audience. And then how do you present scientific data as a story? Because you have to take the data and then create the story. So what is the best way of doing that? Is it through text? We have seen examples of text slides today. Is it through tables? I didn't see that many tables today. Is it through figures? Or what I call diagrams, and I'll explain the difference between a figure and a diagram shortly. You will see that. And we've even seen examples of videos, haven't we? To try and help us tell a story. So which is the best way? You have a set of data. So how many of you thought that text slides worked well today? Hands up. Depends on the data. How many of you think there weren't that many tables, but there were maybe 2 or 3? Not so good, so no hands in the air. Figures. Diagrams. I haven't even explained what they are yet, but still. Videos. So how many of you thought that Eric's 2 videos helped when telling a story. Interesting. I thought they were shit. I thought you should not have used those videos. You know? I thought. You know? And the reason why I thought that was that, yes, they're funny videos, but everyone's watching funny videos. If you want funny videos, go to YouTube. You know? It is acceptable to use a funny video if it underpins your story. If the video is helping you tell the story, yes. But if it's a distraction from your story, then don't use them. That is my advice, at least. So I thought the last one was fine, because that was your finish. That was your big bravo, you know? That's fine. But the first one didn't really help us, I think, in the presentation and in the telling of your story. Now, my vote goes to figures and diagrams. Let that be said. And you quoted, "A picture tells 1,000 words," I think is the way we say it. This, I think, is actually the original citation. A Russian author. I've never read him, I've just read the quotation. And this is the more modern way of saying it. I'm not sure if Ivan agrees with this. Have you ever seen this definition before? And notice how I stopped talking, didn't I? I gave you a chance to read this on your own. And I wasn't talking about something else while you were reading it. So the slides are there to help you. You're not here to compete with them, because you cannot compete with it, in a way. So is it okay? This is workable? And it's my favorite citation as it relates to, you know, figures and slides and how we should be thinking when we are producing our visuals for a presentation. So the rest of this will really be a few thoughts about figures or diagrams, figures and diagrams, I should say, with a few key points. And the first key point is be honest. And I know you're not liars. None of you are liars. But when you present data, make sure you give an honest, true representation of the data. So how do you think this figure here works? It's not good. Why is it not good? Well, the data are true, so that's, and it could be any comparison here, so that's not the point, really. Mm-hmm. There's no source, all right? Trust me on the source. It's more, this is about the layout of the figure. Rod? Right. So the question here is obviously, is there a difference before to after? That's the one research question. And the other question is there a difference between men and women? And showing the data this way, I am not giving a true representation of the data, am I not? First of all, I didn't show you what the error or what the variation in the data was. So that's always important. When you make a diagram like this, you should always include some measure of your error or the data variation, if you like. And the other is what you pointed at. This is a true representation of the data, where I'm starting at 0, and I'm showing the whole range up to 100. And what you can see then is that these differences are, first of all, minimal, and second of all, probably not statistically significant between before to after for the groups or for the whole. And there's no difference, and you can tell that from the error bars or 95% confidence intervals here, that there's no difference between men and women. So be honest. Always ask yourself the question, is this a true representation of the data? And I see so many people who are not representing the data in the correct way in presentations like this. Now, tables are excellent when you write scientific papers, because the advantage of a table is you can give the exact numbers. So people can use those numbers and compare directly with others. They don't have to sit there with their measurement scale and try and find out, is this 66 or is this 67? But for presentations, they're not that good, because it takes so much processing comparing numbers in a figure. One way of avoiding that could be something like this, making it more visually attractive. Not sure if the visual graphics expert thinks that, but and you're now looking around this to find out, well, you're now doing a bit of processing. I could help you by highlighting the ankle here as I'm telling the story, and then highlighting the next region. And now the main point comes out to you very easily, doesn't it? As opposed to a table where I just listed all of these and then the percentages or the numbers in the table. And now the next few slides is just to show you a few examples of how I do visuals. And you may like them. And we have different styles, or you may not like them. But I think the point of showing this and the next few ones are that is the KISS principle, as you just mentioned. When I make slides with graphics like this, I try to abide by the KISS principle. And you remember the KISS principle? Keep it simple and straightforward. Or stupid. I've never heard that straightforward part before. So, clean. And if the data set is very complicated, I will make more than one figure. So this is an example of a presentation. Actually, the slides I've gotten from one of my PhD students. It was a presentation I got from him a few days ago, so it was easy to pick the graphics out of this. The question is quite clear here. The use of visuals will speak directly to Norwegians, because this is a 2-time Olympic champion in rowing. And this is our best cross-country skier. So the symbol, although he's not dressed like a cross-country skier here, the visuals speak directly to the audience. We're comparing winter to summer here. And they're both Olympians. So we're comparing winter Olympians. The visuals underpin the message. They're not competing with the text. They're contributing to the text, if you like. And then this visual shows the prevalence of injuries in the lead-up period to the Olympic Games over a period of more than a year here for the Winter Olympians, where you see that there's an average prevalence of 20%. 1 in 5 athletes at any given time is ill. And how does this compare to the Summer Games? Data collected 2 years before. Well, here you see the Summer Games. So you can see that summer athletes, interestingly, had a higher prevalence of illness than the winter athletes. That was injuries, sorry about that. And this is illness were about 1 in 10, so 10% of athletes. Winter Games were ill, and then this is Summer Games. Just an example to show you how you tell a story with a very simple visual that builds and helps you tell the story. Yes, please. How you actually produce this? Well, you can do this in Excel, yeah. I think my favorite graphing program for scientific graphs is a program called SigmaPlot. SigmaPlot. The user threshold is a little bit higher than for Excel, but the advantage is that you have complete freedom. You can make the graph, adjust the graph just the way you want to. So you have much more of an ability to modify a graph and make it just as you want to. SigmaPlot, it's called. So these were a few examples of graphs hopefully adhering to the KISS principle. Keep it simple. Then the second principle is, now, as a presenter, you want to make it easy for people to follow you. And one of the things then is keeping things uniform throughout the presentation. So the example of the next 4 graphs here is probably a very complicated study where someone has measured something over a period of time. This happens to be days, daily blood samples of a group of athletes. Now, this is then obviously the magnitude of what you've measured, and you're going to be explaining this. Again, a very simple graph, not cluttered, not a lot of information, very clearly focusing on what you need to focus on. But I haven't just measured testosterone. I've also measured other hormones. And by having each of these use the same layout, exactly the same format, makes it easier to tell the story. And in this case, as you may remember, testosterone and androstenedione depend on these hormones and their production. So there's a link here, there's a story that you're going to tell, but you're telling the story through visuals, which help you tell the story in an uncluttered way, and where the visuals build the story. So how much time do I have now, Rolf? So exact numbers? 5 minutes? So the last 5 minutes I'm going to show you a series of slides developed to tell a story. And the story is quite simple. It's a study that shows that 40% of volleyball players have patellar tendinopathy or jumper's knee, but also the data set tells us that they hardly ever miss a game. And the bottom line, the point, the story I'm going to tell you is that the data collection methods we have for this are inadequate. All right. So the visual I could have produced for you for this is this. This is the data showing that jumper's knee affects 40% or affected 40% of male players within the last 2 months. They had a problem with pain in the last 2 months. That means during this season, they had pain problems. Okay? This is another visual I could have shown you, a table that shows you that out of all the players that were surveyed, only 4 of them ever missed a tournament because of jumper's knee. And none of them missed more than 4 tournaments. Okay? This is the data. Now the story, or the alternative approach could be this. I'm not going to give the whole lecture, I'm just going to show you the visuals. I'm going to start out by showing this video. and showing you a dramatic injury. So this is the one contrast. The other contrast is the next video, which is this. Not very dramatic, but possibly many of these athletes here are injured. We can imagine that. They're running the marathon, yet they are injured. The point being that the injury recording systems that we have developed over time, they favor the dramatic injuries, whereas the pain problems that athletes have in, let's say, everyday life are not captured by those methods. The next visual is one to show how we do prospective studies to collect data on injuries. So this is the first athlete on the team who plays an entire season. This is the second athlete who has an injury, then comes back from injury, and then we have the other athletes of the team, and we have a number of what we call time loss injuries during the season. And we can calculate then and give a measure of how many problems we have in the sport. This visual is to show you how overuse injuries are gradual and how they cause pain, but do not, I'm going very quickly now, right? Just to show you the kind of visuals that I would use for a talk like this, but do not necessarily lead to a time loss injury. So they're running with pain, going back to the videos I started using. So this is what it would look like if we did a study where we asked them about how much pain do you have throughout the season, the same 12 athletes as I showed you in the previous picture. But out of all of these pain episodes or these problems, there was only one of them that caused a time loss from competition, which means that although this is a situation, we've only recorded one time loss injury using this traditional method of collecting data on injuries. Yet 40%, or in this case 42% of the athletes at any given time have a problem with reduced performance, pain, and reduced function. All right, so of the two, using the two tables, I've taken the two tables and I've transformed them into a story using visuals, using diagrams to try, and even video, to try to tell that somewhat boring story of the volleyball players that I started out with. But the question to you is a rhetorical question by which I will finish this talk, and that is, which was the better story? Was it the tables, or was it the graphics that I used? Obviously, building a presentation like that takes time. It's not done in 5 minutes in an afternoon. I can spend up to a month, hours every night, fine-tuning the presentation, working on the diagrams, working on the visuals. And why do I do that? Because I want